Sir, I guess it's a bending moment and the twisting moment. Right?
Okay, bending and twisting moment, right? There is a
Yes, sir.
new term that
Mm.
has just come up. What is bending moment and what is twisting moment? What do you mean by twisting moment?
The twisting moment is actually like applying axle sides, and
Okay,
when we are actually calling in a bending moment, then it's which is like applying in a transversal like axis.
okay, correct. So, अच्छा सबको रिकॉर्डिंग ऑन का मैसेज आया?
Yes, sir.
Okay, cool. So what he just meant by फिलहाल ये समझो bending moment and what is bending moment. So bending moment where tension and compression act together. If it is bent like this, there is compression. If it bends like this, tension और compression के positions switch हो जाएंगे. Okay. You can imagine if it goes like this, you see that the curvature is trying to compress this part. Okay. And if the curvature goes like this, you see that the curvature is going to stretch this part, that is elongate or tension. Okay. So now you get it. Now what do you mean by something what uh, he is saying is twisting moment? Okay. Now bending is this. Now I'll draw a diagram और तुम twisting खुद से समझ जाओगे. And if you still don't understand, फिर भी समझने की कोशिश करना. Because it is pretty easy. Okay. Cross section दिख रहा है? अच्छा डबल हेडेड एरो का मतलब क्या होता है पता है किसी को? डबल हेडेड एरो मींस राइट हैंड रूल. लाइक
Twisting
यहाँ पे
moment.
जो तुम yeah, kind of like that. So let's say you point your thumb towards the direction of the double headed arrow. Your thumb will be in this direction. Okay. Right hand, always the right hand. Okay. Right hand thumb in the direction of the arrow. That means your four fingers will be in that direction, right or not? ऊपर की तरफ होंगे चार fingers तुम्हारे. Until and unless you're Hrithik Roshan, you'll have six. So you have a thumb in the direction of the arrow, and your all the four fingers will be on the upward side. Now you curl the fingers. You will see that your finger comes like this. So right hand thumb rule or double-headed arrow का मतलब ये होता है. Okay. Double-headed arrow means this. So if I remove this part, तो अब तुम्हें पता चला double-headed arrow. If I represent it like this, it should be automatically understood कि moment इस direction में होगा. If I represent it like this, it should be understood कि moment इस direction में होगा. Right or not? Yes or no?
Yes.
Yes, ma'am.
कैसे यस कर रहे हो यार, तुम लोग गलत चीजों को यस कर रहे हो. दोबारा करो, हम इस डायरेक्शन में डालो. मैंने गलत बनाया, तुमने यस यस कर दिया.
The rotation is actually in the other side, I guess.
एग्जैक्टली. तो यस यस पहले देखो क्या हो रहा है. ठीक है. सो नाउ डू यू अंडरस्टैंड बेंडिंग और ट्विस्टिंग में फर्क क्या है? द सिंपल डिफरेंस इज बेंडिंग इज दिस. इफ यू ड्रॉ एन एक्सिस, बेंडिंग विल बी लाइक दिस. It will bend around an axis, but if you draw an axis like this, twisting will happen on the same axis. You get the difference now? You get the difference between bending and twisting? Basva, Varun, Madhuri, Himanshu,
Yes.
Bhavya, everybody.
Yes, sir.
Yash.
Yes, sir.
हाँ भैया.
ठीक है, cool. भाई लोग तुम लोग ऐसे डर मत जाना. कोई भैया बोल रहा है, कोई सर बोल रहा है, तुम्हारी मर्जी है, जो बोलना है वो दो. तुम लोग सुमित भी बोल सकते हो मुझे. ठीक है. So now you understood the difference between bending and twisting. So now I'll go to the cross section which I was drawing. Unsymmetrical cross section. Now there is an unsymmetrical cross section. There is a condition. Every cross section on the planet will have a neutral axis. When it is subjected to some kind of stress, every cross section will have a neutral axis. Neutral axis की definition क्या होती है? संकल्प, you tell me. Sankalp, if you're speaking, you're not audible. हेमंत, हिमांशु, बासवा, न्यूट्रल एक्सिस की डेफिनेशन क्या होती है? When do you say that this axis is a neutral axis?
Oh, hello.
Yeah, I'm audible. Yeah, you're audible.
Oh, the stress due to bending is not there.
Stress due to bending or direct stress?
Direct stress.
Sir, I guess moment of inertia is 0.
Zero.
Moment of inertia is 0.
Actually, there is no tension and there is no compression.
No tension and no compression. तो क्या ये मैंने सही बनाया न्यूट्रल एक्सिस? इसमें न्यूट्रल एक्सिस कहाँ पर है? Where is the neutral axis? Let's name the locations. 1, 2,
Like there is
or
no
3.
longitudinal stresses and strains.
Okay. Point 2, exactly. This point 2 will be the position of neutral axis. Now, how do you define a neutral axis? Let's say I give a direct stress over here. मैंने एक P stress दे दिया, तो क्या ये neutral axis रहेगा तब भी? नहीं रहेगा. क्यों नहीं रहेगा?
Because there will be some kind of strain there.
There will be some kind of strain there. Okay. Anyone else?
No, strain would be 0 at neutral axis.
Strain would be 0. Anyone else?
सर आई गेस मोमेंट ऑफ इनर्शिया होना चाहिए. स्ट्रेस हो रही है तो शायद उसकी एक इनर प्रॉपर्टी ना, इंटरनल प्रॉपर्टी है, तो मुझे लगता है कि मोमेंट ऑफ इनर्शिया होगा.
Okay. Moment of inertia होगा. See, तुम्हारा point पहले मैं contradict करता हूँ because ये गलत है. Let's say there are certain channel sections. Let's say if there is a unsymmetric T section, तो यहाँ पे इसका centroid यहाँ कहीं होगा, right? It is not possible. For an example बता रहा हूँ. It is not possible कि neutral axis और centroid coincide करे. Let's say neutral axis यहाँ पर है. So now do you see that there is still a moment of inertia which is existing? Okay.
Yes sir.
Okay, तो ये हर सेक्शन के लिए तुम्हारा जो पॉइंट है वो सिमेट्रिक सेक्शंस के लिए पॉसिबल है, करेक्ट है, बट फॉर एवरी सेक्शन इट इज नॉट करेक्ट. ओके. नाउ जो ये मैंने डायरेक्ट स्ट्रेस का लोड बनाया था यहाँ बीच में, एग्जैक्टली व्हाट पीपल सेड दैट दिस विल नो लॉन्गर बी अ न्यूट्रल एक्सिस बिकॉज न्यूट्रल एक्सिस पर जिसने ये बोला था, he or she said it right that neutral axis will not have any kind of tension or compression. Okay, neutral axis is a point where there are no direct stress and no bending stress applied. So this is the neutral axis. Okay. So coming back here, let's look at this diagram and try to draw some kind of a axis. Okay. All right. दिख रहा है ना सबको? ये है y axis and ये है x axis. As per this diagram, ये ऊपर जो diagram बना है y and x. Right. यहाँ पे है y and here it is your x. So we are going y and x axis. So when you go to y and x, and let's assume there is a some area over here, considering a small area for simplicity, right? Let's say that this distance, first of all, the neutral axis or centroid, this, let's say this is the centroid. Neutral axis और centroid को मैंने एक distance दिया है zeta. Okay, this distance is zeta. No, not zeta. This is zeta. This upper part is zeta. Let's say this distance is p. As per the diagram, they have shown p ताकि तुम बाद में confuse ना हो जाओ. This is P and this distance. यहाँ से neutral axis से area तक. This area which is your dA. This area dA. This
Neutral
distance is
axis
theta.
perpendicular to the cross section.
What? Yeah, it is. It is. ये बस मैं दिखाने के लिए बोला क्योंकि यहाँ पे एक point होगा ना which will be coming out of your screen. Okay. So neutral axis will be actually. It will not be like this. This is just a representation. If you want a clear picture, neutral axis will be somewhat like this. Okay. Do you get it? Yes or no?
Okay. Yes.
Okay. Yeah. So just to represent neutral axis for clarity of drawing, I cannot represent it as a dot. Okay, which बहुत confusing हो जाएगा if I write a dot over here. So it's better that I draw it like this. This is just for clarity. All right. So let's say this distance is zeta. अगर तुम्हें zeta दिख रहा है, zeta is the distance between this neutral axis and dA, and P is the distance between centroid and the neutral axis. So बहुत सिंपल सा है फंडा. हमें प्रूव करना है कि न्यूट्रल एक्सिस एंड सेंट्रोइड आर कोइंसाइडिंग. सो हाउ विल यू प्रूव? नाउ यू हैव टू रन योर ब्रेन्स. दिमाग चलाओ एंड लेट मी नो हाउ विल यू प्रूव कि न्यूट्रल एक्सिस एंड योर सेंट्रोइड इज गोइंग टू कोइंसाइड. Varun, any guesses? Ankita, yeah, tell me.
The area produced by these 3 points will be 0.
Area.
Net
Area 0 कैसे होगा?
force
Yes,
moment.
uncle. हाँ.
Net force moment about neutral axis should be 0. If
Force
about
moment.
center of gravity and if about center of gravity and about the neutral axis both are 0, then we can say both are
CG
coincident.
कहाँ से आ गया? मैंने तो मास दिया ही नहीं है ना इस फिगर में. I've just given a cross section, that is area. तो मैंने CG तो बोला ही नहीं, मास
Yeah,
तो नहीं.
center of area. Yeah.
Center of centroid. You mean centroid? Yeah.
Yes.
Center of area is centroid. Okay. So you mean centroid पे क्या करना है हमें?
We can take a force moment for each and every area.
Okay.
And we can take their force moment about center of area, and then
I want this
still
P to go
and
0.
again we
You're trying to say yeah.
yeah.
Force moment area.
Yeah, then again we will do the same procedure for neutral axis for taking force moment about neutral axis for each and every small area. If both are 0, then we can say that both points are coinciding.
Force moment area. All right. You're trying to go with the force moment approach. Try to think from the stress approach. मैं stress के साथ क्या कर सकता हूँ?
Then stress would be then force would be in terms of stress, like stress multiplied
Force in
area.
terms of stress. No, I want only stress.
Yeah, we can convert force in terms of stress. No, stress multiply its area, the area.
Okay.
Stress will be 0. on
Stress will
centroid.
be 0. Exactly. So अब वहां से मुझे आगे लेके जाओ. क्या करना होगा?
Then we will prove that the stress at the centroid will be 0.
Correct. Exactly. See what she's told us, right? See what you are doing is you are going force moment area, okay? But force moment के लिए you need certain point and certain forces over here. What you said with force moment is absolutely correct, but it will become lengthy. But what who answered right now about stress? I didn't see the name. So whoever answered, yeah, the meaning was that this p distance, okay? Instead of p, let's notice at the answer 0 zeta. My point is zeta should coincide with C. Zeta and C should be same. That means automatically the neutral axis and C are going to coincide. So I'll consider zeta. So let's go with sigma Z. Can anyone tell me what is sigma Z? Sigma Z की value क्या होगी? Sigma Z which is coming out of your screen. Sigma Z is in this direction. यहाँ जो आ रहा है बाहर. Okay. So what will be sigma Z? as per your Euler beam theory, can I write sigma z as this Young's modulus zeta divided by the curvature rho? Yes or no? Yes or no, guys?
Can you explain again what is zeta here? I mean, I'm
Zeta
a
is the
little bit
distance
confused.
from neutral axis to the area. Neutral axis to area.
And center of area to neutral axis is P.
Yeah.
Okay.
Zeta is this distance here to here. Okay, this is zeta. Now, why zeta and rho? Rho is your curvature of the this. This is the curvature. This is rho. Radius of curvature. Okay, this is your rho. Now we are looking for stress in the z direction. So I will obviously have to look at the strain in the z direction. Yes or no? So you have to explain me, how do you see this as a strain? Theta and rho. How is this a strain? Can anyone explain me? I just gave you a hint in the words itself कि यहाँ पे symmetrical beam theory लगेगी, which is your Euler beam theory. Symmetrical. So how do you explain zeta by rho is the strain?
Zeta and rho, like rho plus zeta is the radius of curvature for a small area.
Rho plus zeta. Are you sure, Himanshu?
I suppose I may not, I may be wrong.
Okay. Achha. So now you'll learn one thing extra. I mean, it is necessary. So, symmetrical beam theory ka there is one assumption. I'll write the assumption here. And the assumption is don't worry, I'll just move this. How do you move? Okay. The assumption to this is that planes will remain perpendicular, that the plane section are assumed to remain plane after bending and by comparison with symmetrical bending theory. Okay. अच्छा ये समझ में आया सबको ये लाइन ये assumption है Euler beam theory का this is the assumption that the planes will remain symmetrical and normal to the z axis even after bending. Okay, so let's say that in this entire beam, this I'm drawing a beam, there is a small section over here. There's a small section over here. Now even after the beam has bent, let's say the beam is right now very straight. Okay, now the section you see here is normal to the front axis. This is normal. Now even after bending, let's say it is bent like this, sudden bend है, I won't see the section go like this. मुझे section इस तरह से नहीं दिखेगा. This is not the assumption. The assumption says that even after bending, my section will look like this itself. Do you get it? Yes or no? And it will still be normal to the axis. Yes or no?
Yes.
Okay, so this means the
Yes.
same, that the plane will remain symmetrical and normal to the z-axis even after the bending. यहाँ पे मैंने z-axis specify किया है, please इसको circle कर लेना because हर केस में नहीं होगा. It depends on the axis system you have chosen. If my x-axis was outside, तो यहाँ पे तुम्हारे definition में x-axis आता. Okay. So just circle this and write down that this depends on the axis system on which we have chosen. Okay. It depends on your axis system. Right. So this was the definition, and because of that definition, you see that your row curvature. Now you understand. इसका original length क्या रहा होगा? Your original would have been this, some kind of row, and this is the zeta which is experienced over here, right or not? Cross section के हिसाब से. Now do you understand why this is a strain? Zeta by rho is the strain. Okay. Yash, any doubts? Guys, am I audible?
Yes.
Yes.
Yeah,
Okay.
yes, sir.
Okay.
Hello.
Yeah, tell me.
I have a doubt that due to this bending, the radius of curvature should be same now for every every area lying on the neutral axis.
Yes, it should be correct.
Then due to bending, every area above and below the neutral axis is experiencing the stretching or
Compressive, yeah.
compression, not just say
Yeah.
compression, like shrinking.
Shrinking, okay, no. Yeah, shrinking is different. So you have to say compression because shrinking and warping is a different phenomena. So it is experiencing tension and compression equally. That is right. Correct.
Hello.
Yeah, please go ahead.
There was some glitch. I don't know why.
So I'm saying shrinking and warping is a different phenomena. Yes, you are right that every area will be experiencing tension or compression as per their location equally. Okay. Now next, what is your doubt?
Actually, I'm having a hard time hearing you. So can you please repeat last 30 seconds what you just said?
Okay, just a minute. Am I audible to rest of you? Ankita, Nandini, Deepak,
Yes.
Ankita, Nandini. Paswa, am I audible? Okay, I'll just repeat what I said. आवाज आ रही है मेरी? Who had the concern of mic?
Yes.
Okay. Yeah.
No problem. Yeah. Audible.
Okay, so I just said that. See, you are right about having key. Every area will face some kind of tension and compression. Yes, shrinking and warping is a different phenomena that is not here to explain right now. Okay, that is out of the scope of syllabus. But about what you said, that every area when it is bent around the radius of curvature will experience some kind of tension or compression equally. Okay. So now what is your doubt?
Then like zeta rho is the neutral axis radius of curvature, and zeta is
Zeta rho what?
surplus or less, like some setback. Like
What would I am not
rho is the
understanding
radius
your
of
doubt.
neutral
Yeah,
axis.
rho is the radius of curvature, not
Rho
the neutral
is the
axis.
radius of curvature.
Yeah.
Yeah.
Okay, next.
Okay. Rho is the distance between center of curvature to the neutral axis, right? That's what
Yes.
radius of curvature.
Yes. Yes.
Okay. Okay. And zeta is the
Distance from neutral axis to
like
the area which we
extra.
are considering. Theta is the
Yes.
distance
Yes.
from the neutral
Then
axis.
does it mean? Hmm. So does it mean that area got shifted from neutral axis to the zeta location? So that's why we are calling
No,
it
area
as a
was
strain.
already at the zeta
That point
location.
I'm not getting.
Area is already there. The area is already considered over here. This is the area that we are considering. Now around this area, I have considered zeta, distance from the neutral axis. Area is already there. There is no shifting of area. Okay, you did not understand why zeta and rho are strain ratios, right? See, am I audible? I'll just explain you this part. You have to tell me that I'm audible and then I'll go ahead.
Audible.
Okay, so I'll explain you why zeta and I'll explain you why zeta and rho are your zeta and rho. Okay, we all know that this is your strain. Sorry, this is your epsilon of z, strain in the z direction. Why is it so? ऐसा क्यों हो रहा है? Because let's see here. If you have this cross section and my neutral axis is over here, and I have considered an area over here. Okay, let's go look at the beam. Let me draw a beam over here. Okay, so now in this beam, this I'm drawing the same area. ये जो area है ना, ये वाला area, I'll draw the same area over here. Okay. तुम्हें assumption तो समझ में आ गया था ना, that this area will remain perpendicular even after bending. So I'm removing that. I mean, I'm not going to tell that assumption once again. Okay. So let's say this is the neutral axis. Neutral axis, and now I see that the beam has bent. Let's say the beam has bent somewhat like this. Okay. Is this visible? Your beam has bent. And the area has not shifted. मैं बस दिखाने के लिए, just to show you, I'll draw the area bit here. There's someone in the lobby. Guys, am I audible?
Yes.
Yeah.
Yeah, there was some power cut for some time.
Okay. Sorry, there was a mic glitch. Yeah. So now you see that the beam has bent. Okay. Beam has bent, and now I'll show you something. See, you have this area right now. Sorry, this distance right now, which is what this is. Let's say this is some distance. Now, right now, this the radius of curvature over here is something infinity. When your beam is not bent, your radius of curvature is infinity. And when the beam is bent, you have some radius of curvature. Zeta will remain as it is like that even after this. Okay. So what is your strain? Your strain is the deformation by the original area. So we are considering this as a deformation. Okay, we are considering zeta as some kind of a deformation towards the radius of curvature, right? Because when it is not bent, you will not consider zeta, that is a strain over here. But when you bend it, this area, when you bend it, this area has a certain radius of curvature. Let's say rho of A. That rho of A will have a strain because zeta is also located somewhere to the neutral axis. न्यूट्रल एक्सिस से ये एरिया zeta डिस्टेंस पर दूर है. The area is a bit far, is at a distance zeta from the neutral axis, is at a distance of zeta from the neutral axis. Now because ये already zeta distance पर है, because of the distance and the additional radius of curvature this area will be facing, इन दोनों की वजह से there is going to be a certain strain in this. Now this is not deformed because हम कर रहे हैं एक rigidity वाला portion, that every point in the beam or in the structure will remain as it is even after deformation. तो वो rigid हो जाता है. But here हमारा rigidity का concept नहीं है because it is an elastic beam and this elastic beam can bend anywhere. And if it is bending, there will be certain kind of differences in the distance. This zeta will change. So here we are not considering zeta at a straight beam because radius infinity है. But जब हमारा radius of curvature exist करता है, we have called it कि चलो ये zeta distance पर है. We have considered this at a distance zeta. That is why zeta, which is your deformed length, is at a distance of to the original length of rho. This is your strain in the z direction. Now do you understand, yes or no? समझ में आया guys?
Yes, sir.
Okay, cool. So now coming back over here, we had strain. हम क्या कर रहे थे? Neutral axis कैसे determine करेंगे? How will we find out the neutral axis? So जब stress वाला idea था, that let's take the stress. Now we know that at the neutral axis का definition ही यही था that your direct stress is going to be 0. That means your summation of all the direct stresses in the neutral axis will be what? 0. Am I right or not? For the entire area. Stress into area is what? Force, right? So this is what I meant when I was saying कि हमारा जो stress है, force है, उसको stress के terms में लिखो. So this is the term, right? So your entire stress in the area will be 0. Pure bending moment है, so normal loads on any section must be 0. Okay. So when you substitute the formula of zeta, what you'll get this E बाहर आ जाएगा and you'll get zeta by rho into dA 0. Okay, which will simply mean that your zeta into dA, because E and rho are constant और एक given values होंगी तो वो 0 में चली जाएंगी and zeta will be 0. That means this zeta की value आ रही है 0. If zeta comes out to be 0, that means what are we seeing? We are seeing this thing. we are seeing this thing, that when zeta gets 0, that means your neutral axis and your centroid are going to coincide. Your zeta is directly coming out over here. Okay, you see your first moment of area of the cross section of the neutral beam is 0. तो मोमेंट ऑफ इनर्शिया का वो पता है ना डेफिनेशन. मोमेंट ऑफ इनर्शिया का डेफिनेशन क्या होता था? मोमेंट ऑफ इनर्शिया वाज, लेट्स से योर फर्स्ट मोमेंट ऑफ इनर्शिया y of the area. If this was 0, that means your first moment of inertia of the y distance is 0. That means हमारा जब first moment of inertia across zeta was 0, that means my zeta was coinciding. तभी तो moment of inertia 0 होगा. Do you understand or not? I'll explain it once again. Let's say this is the area, this is the centroid, and this is the axis, and this is the distance, let's say d, and the area is a. I'll say dA. Okay, so if I have an integral d into dA, let's say this integral has some value I, that means moment of inertia about this axis does exist. इसका क्या होगा? 1 1 I 1 1. Yes or no? ये centroid है. Yes or no, guys?
Yes.
Okay, now with the same thing, same figure, but my axis 1 1 is coinciding with the centroid. तो यहाँ पे कोई moment arm बना? When there is no moment arm, that means your d is equal to 0. जब यहाँ मोमेंट आर्म ही नहीं है तो इंटीग्रल की वैल्यू 0 नहीं हो जाएगी? यस और नो?
Yes, sir.
ओके, जब इंटीग्रल की वैल्यू 0 हो गई, दैट मींस योर फर्स्ट मोमेंट एरिया इज 0. सिमिलरली अब तुम समझे, दैट मींस योर डी इज कोइंसाइडिंग एट द सेंट्रोइड, दैट मींस ये डी 0 हो गया. तो यहाँ पर जीटा 0 का मतलब ये नहीं कि डिस्टेंस 0 हो गया, इट मींस दैट इट इज कोइंसाइडिंग विद द न्यूट्रल एक्सिस. यस और नो? Yes or no, guys?
हाँ भाई.
ठीक है. So I'll just rub this part. No, I won't rub it. I'll just yeah, I'll rub this part.
So we can also say center of area and neutral axis are coinciding.
Not for every kind of section. Not for every section. मैंने example दिया था starting में ही. एक अगर eccentric T section है तो इसमें क्या करोगे? इसमें centroid यहाँ होता है और neutral axis यहाँ होता है. For an example. अब हर section के लिए ये true नहीं है ना. Centroid and neutral axis का coincide करना. It's not true for every section.
Okay.
Okay. But what you're saying is right. I'll tell you why. I'll tell you right now. I'll tell you right now. Don't worry. Not true for every section. Why I'm telling you not true for every section is because there is certain differentials. Wait a minute. Screen गए क्या? Okay, is the whiteboard back again? Can you see the whiteboard?
Yes.
Okay.
Yes.
So why I am not saying कि for every case neutral axis and your centroid are going to coincide, because for some sections ये तो चलो straight sections है, but let's say if the section is something like this, if this is the section or an S section, तो यहाँ पर नहीं होगा ना centroid और neutral axis coincide. But what I can tell you is, since हमने ये चीज अभी prove की है, that the strain for a bending radius of curvature, your centroid and will coincide with the neutral axis. So yes, please write down over here. Centroid and neutral axis will coincide. Okay, so this is your rule. Just remember this part. But now do you see something different? पहले हमारा क्या था, my axis was like this and neutral axis was here, but we see that my axis is inclined at a certain angle alpha. Yes or no? न्यूट्रल एक्सिस मेरी एक्चुअल एक्सिस से अल्फा पे इंक्लाइंड है, ठीक है। उससे हमें ये पता चलता है कि क्या मैं जीटा को वेक्टर कंपोनेंट में लिख सकता हूँ। इफ यू गो ओवर द फिगर, you tell me what will you write zeta as? If you have drawn the figure, I'll just write it. Zeta should be x sin alpha. Please साथ में लिखते जाना because ये ऑटो करेक्ट कर रहा है।
Alpha is the angle between zeta and neutral axis, or x-axis and neutral
ये
axis?
देखो ना, ये देखो क्या लग रहा है तुम्हें, क्या लग रहा है देख के।
Okay, since
Yeah.
zeta.
Exactly. And this is y cos alpha. क्या मैं ऐसे लिख सकता हूँ zeta को? Yes or no, guys? Obviously I can. Can you tell me? Zeta. Tell me what is zeta. Will it be x sin alpha plus y cos alpha? Yes or no? Try to work this out right now. यहाँ तक पहुँचोगे तो मुझे बताओ आगे। Guys, everybody?
Sir, x square and sin square alpha and the y square and the cos square alpha, I guess.
No.
Mhm.
Try again. This is only the answer. I am asking you,
Or a square
write
root of
x
this.
and
I
y
think.
in terms of zeta. Sorry, write zeta in terms of x and y using alpha. Make components of zeta. Think.
Zeta upon
Think.
x, sin inverse zeta upon x.
Why are you
And
going sine inverse? Now alpha is your sine inverse zeta from zeta by x, right? So just simply say no, zeta is equal to x sine alpha. Yes or no? Yes or no? You just now said it, no? Ki, x, alpha is sine inverse zeta by x. Correct?
yeah,
That
yes, sir.
means zeta is x sine alpha. You get this? अरे imagine like this, no? Zeta यहाँ पर है, y axis यहाँ बनाओ. Make a y axis here, make a z axis here. Sorry, x axis here. Now tell me, can you divide it now? अब आसान हो रहा है. This is your zeta, this is your x axis, and this is your y axis. मुझे वेक्टर डिवीजन तो नहीं सिखाना चाहिए, आई थिंक.
X by zeta is sin 90 minus alpha, is it so?
तो sin 90 माइनस अल्फा क्या होता है?
Angle between y and zeta.
What is sin 90 minus alpha? Trigonometry, 10th class.
Cos alpha.
Sin pi by 2
Cos
minus
alpha.
alpha. Exactly. So you get it?
हाँ भैया.
आ गया?
हाँ भैया.
यार क्या कर रहे हो, मुझे ट्रिग्नोमेट्री सिखानी पड़ेगी अब. चलो ठीक है, नो वरीज. तुम लोग इसे दोबारा एक बार देखो, समझ में आ जाएगा. आसान सी चीज़ है, कोई बड़ी बात नहीं है. ठीक है, नाउ लेट्स गो अहेड. अब इस चीज़ को इसमें पुट करो. यू आर गोइंग टू डू इट बिकॉज आई कैन नॉट टाइप. इस चीज़ में पुट करो तो जीटा बाय वाई, सॉरी जीटा बाय रो है. इट्स रो. So you get the answer. सिंपल है, सब्स्टिट्यूट कर दो, नो इश्यूज. हो गया? Don't simplify, just write it here. That's it. Right or not?
हाँ.
This will be e by rho
हाँ.
into तुम्हारा पूरा sin alpha वाला टर्म. Yes or no? है ना?
Yes.
हाँ, ये हो गया तुमसे. Now let's go to moments. लेट्स गो टू मोमेंट. हमने कहीं पे मोमेंट देखा था, राइट? mx एंड my. सो mx को ध्यान से देखो, दिस इज z. व्हाट डू यू थिंक विल मूव द mx? mx बनने के लिए देयर शुड बी अ फोर्स इन द z डायरेक्शन, राइट? सिग्मा x होना चाहिए, सिग्मा z होना चाहिए. आई मीन, कैन यू थिंक if there is a sigma z at a distance of y, तो क्या मैं mx बना सकता हूँ? yes or no? can I write
Yes.
mx? क्या? mx to be a moment of sigma z into y into जो एरिया होगा वहां पे, let's say area dA. can I write this? because force है ना, sigma z into area dA, this will be the
Yes.
force. हो गया? yes or no?
Yes.
समझ में आया?
Yes.
perfect. so come down here and write with me that your mx will be what? Integral of sigma z, first force sigma z into dA. This is the force, right or not? force into momentum. समझ में आ गया guys? आवाज नहीं आ रही है मुझे.
हाँ भैया.
ठीक है. एंड योर my का फॉर्मूला यही होगा. यस और नो? करेक्ट करके बताओ मुझे. सही लिखा है मैंने?
हाँ भाई.
परफेक्ट. फिर मैंने सही लिखा है. सो नाउ यू पुट द दिस सिग्मा z जो यहाँ से तुमने निकाला था, यहाँ जो तुमने सिग्मा z निकाला था, उस सिग्मा z को इसमें पुट करो, mx और my में. when you put it, what do you get? mx और my. उससे पहले तुम्हें एक वो दे देता हूँ मैं, सिंप्लीफाइंग वाला फैक्टर. सिंप्लीफाइंग फैक्टर इज गोइंग टू बी दिस. तुम्हारे इक्वेशन में ये चीज दिखाई है अभी तक आया समझ में? when you are substituting sigma z, ये चीज सामने आ रहा है या नहीं आ रहा है? x square dA, x square dA, y square dA. yes or no? आफ्टर सब्स्टिट्यूटिंग क्या तुम्हें ये
Yes.
सब टर्म्स दिख रहे हैं तुम्हारे इक्वेशन में?
Yes.
ये टर्म दिख रहा है, नहीं दिख रहा है?
दिख रहा है.
हाँ. सो नाउ सब्स्टिट्यूट दोस टर्म विद ix, iy एंड ixy. ओके. सब्स्टिट्यूट द टर्म्स विद ix, iy, xy. उसके बाद जो फाइनल इक्वेशन आएगी उसको मुझे बताओ. फाइनल इक्वेशन मुझे पहले mx की बताओ, देन मुझे my की फाइनल इक्वेशन बताओ. टेल मी द फाइनल इक्वेशन ऑफ दीज टू, mx और my. जल्दी बताओ यार, आसान सा है.
E by rho I xy sin alpha plus iy cos alpha.
ओके. ये किसका है? mx का, राइट?
Yes.
ओके. तो तुम्हें mx मिल गया. अब my बताओ मुझे. my यही आया है सबका?
E by rho I xx sin alpha plus I xy cos alpha.
परफेक्ट. तो my सबका ये आया, mx एंड my. गाइस सबका आ गया आंसर ये वाला?
हाँ.
ठीक है. नाइस. तब सबका आंसर अगर ये आ चुका है, आफ्टर दिस व्हाट यू आर गोइंग टू डू इज, मुझे सिंपली तुम सिग्मा निकालो. अब What is the sigma z? सिग्मा z को उसके टर्म में लिखो, ई एन साइन अल्फा के टर्म में. अच्छा, ये इफ़ यू आर थिंकिंग कि मैं वैसे बुक के स्क्रीनशॉट्स लेके तुम्हें बता रहा हूँ, सो माय ओनली पॉइंट इज कि यू हैव टू स्टडी दिस एंटायरली वंस अगेन, बिकॉज मैं यहाँ पे तुम्हें सिर्फ छोटे छोटे कॉन्सेप्ट्स और ट्रिकी पोर्शन समझाऊंगा. पढ़ना तुम्हें दोबारा पड़ेगा और बुक से ही पड़ेगा. सो आई एम जस्ट गिविंग यू अ बिट ऑफ ईजियर जॉब कि मैंने एक बार बुक रेफर कर दी है, एंड लेटर ऑन यू जस्ट हैव टू लुक एट द बुक एंड देन तुम्हें चीज़ें समझ में आ जाएंगी. सो बुक में एक पोर्शन है ये वाला, राइट. आई जस्ट पेस्ट अ स्क्रीनशॉट अनदर वन, और तुम मुझे ना यहाँ तक पहुँच के दिखाओ. ये जो तुम्हें यहाँ दिख रहा है, मुझे ये इक्वेशन अभी चाहिए. तुम में से कैन यू टेल मी, कोई यहाँ पे पहुँच जाए तो इस पार्ट पे क्या लगता है, व्हाट वुड हैव हैपेंड ओवर हियर? सी, बहुत आसान है. ये एम एक्स और एम वाई है, मैंने पूरा मैट्रिक्स फॉर्म में लिखा और यहाँ पे इन्वर्स ले लिया है. आई हैव टेकन इन्वर्स और साइन कॉस अल्फा को मैंने भेज दिया राइट हैंड साइड पे, लेफ्ट हैंड साइड पे. ओके, तो पहले एम एक्स एम वाई को तुम मैट्रिक्स फॉर्म में लिखो. एम एक्स एम वाई इज इक्वल टू योर ई बाय रो कर दो बाहर, आई एक्स वाई आई एक्स एक्स I y y and I x y, and then this is sin alpha cos alpha. यहाँ तक सबको समझ में आया? Yes or no? और 2D मैट्रिक्स का इन्वर्स कैसे लेते हैं? इन दोनों को स्विच कर दो, माइनस साइन से मल्टीप्लाई करो एंड डिवाइड बाय द डिटर्मिनेंट विच इज आई एक्स वाई आई एक्स एक्स आई वाई वाई माइनस आई एक्स वाई का होल स्क्वायर. राइट, इन्वर्स दिया, साइन अल्फा कॉस अल्फा हीरो वहां भेजा और एम एक्स को राइट हैंड साइड पे ले आए. समझ में आ गया कि ये इक्वेशन कहाँ से आई? Yes or no?
Yes, भैया.
Cool. So now what you have done is you have, पहले हमने ये इक्वेशन निकाली थी, राइट. ये वाला पार्ट यहाँ पे याद है तुम्हारे इस इक्वेशन में क्या दिखाई दे रहा था? इन दिस पार्ट ई बाय रो साइन अल्फा ई बाय रो कॉस अल्फा, यस और नो? ये दिख रहा था ना इन योर इक्वेशन 2?
Yes.
यहाँ पे तुम्हें ई बाय रो साइन अल्फा ई बाय रो कॉस अल्फा दिख रहा है, नहीं दिख रहा है? सो अब वैल्यूज उठाओ, पिक द वैल्यूज ऑफ ई बाय रो साइन अल्फा and e by rho cos alpha and put these in equation number 2, which is what? I minus ix mx, right? Can you do it right now? If you do it, you will get something this. This is what you will get. Is everybody getting this same answer?
Please repeat what is procedure for sigma z. What
यहाँ
we
तक पहुँच में आ गए? यहाँ तक आ गए?
हाँ यहाँ तक आ गए.
यहाँ तक आ गए. Now E by rho sin alpha will be everything of the first column. Yes or no? First row.
हाँ
And E by rho cos alpha will be the second row, right?
हाँ
हाँ, तो E by rho sin alpha and E by rho cos alpha की values उठाओ और इसमें डाल दो. You will get it,
Okay.
right or not?
Okay.
And when you put it there, so this will be the equation which you'll get, sigma z. Okay?
Yeah. Okay.
Right. यहाँ तक आ गया समझ में, या सबका आंसर आ गया? सबका आंसर आ गया?
Yes, sir.
Guys, tell me. Okay, cool. So next तुम्हारा बहुत सिंपल सा है, इस इक्वेशन को यहाँ पे कन्वर्ट करना है. The only thing is you have to separate your my's and mx. अलग अलग कर दो. my वाले टर्म साथ में, mx वाले टर्म साथ में. Why are we not keeping it in x and y वाला टर्म? हमने x and y के साथ segregated नहीं रखा है. We are segregating it with respect to mx and my. Okay. Why are we doing that? Because तुम्हारा बर्नौली बीम इक्वेशन क्या था? Sigma by r. Does anyone know the formula? मैं गलत लिख रहा हूँ या सही लिख रहा हूँ, ये मुझे कंफर्म करके बताओ. मैंने सही लिखा है, गलत लिखा है? सिग्मा बाय E इज इक्वल टू I by M इज इक्वल टू Y by R. Yes or no? सही है, गलत है?
सही है.
गलत है.
M by I आना चाहिए.
Exactly. So yeah, जिसने सही बोला था, did you find the mistake?
Yes.
Okay, cool. तो ये लिख लो. This is your Euler-Bernoulli formula. Euler-Bernoulli beam equation. Euler beam theory equation. Okay. And this is for symmetrical bending and one-sided loading. इसलिए अब यहाँ पे M is generalized. Now why I'm segregating it with respect to M is because of this equation. Now my sigma Z is entirely M by I by R. ठीक है, समझ में आ गया? This is the thing which I'm doing here. So because of that formula, I just want for simplicity, I will keep it here. यहाँ तक आ गया सबका इक्वेशन? Did everybody get this part? सबको ये मिल गया?
Yes.
Okay, if everybody has got this, now let's go to something interesting over here now. ठीक है? Now if I tell you to find out the neutral axis, how will you do it? What is your first approach? Neutral axis का definition क्या था? That your bending stress will be 0. इसको 0 put करो, then automatically. अच्छा एक बात बताओ, तुम मुझे 0 कहाँ पे put करोगे? Will you put the 0 in this equation or this equation? You'll put the 0 in equation A or in equation B. Where will you put the
Equation
0?
B.
Equation B. B और A तो दोनों सेम इक्वेशन है ना, तो फर्क क्या पड़ता है? दोनों तो सेम इक्वेशन है, बस हमने एक को x और y के टर्म में सेपरेट किया और एक को mx और my के टर्म में. दोनों तो सेम इक्वेशन है. I'll tell you why you have to put your sigma z 0 in A direction, in A equation, because you have to find out the location of the neutral axis. That means your y and A, and you have to find out the x and A, because as it is, किसी ने मुझे पहले ही कहा था कि अबाउट द न्यूट्रल एक्सिस तुम्हारा मोमेंट आर्म 0 हो जाता है, तो तुम्हारा मोमेंट कुछ एग्जिस्ट नहीं करेगा इफ यू स्टार्ट टू पुट योर सिग्मा जेड हियर. मोमेंट होगा बिकॉज दिस mx and my इज नॉट ऑन द न्यूट्रल एक्सिस, इट इज ऑन द x and y एक्सिस, राइट. यहाँ पे क्यों नहीं रख सकते? बिकॉज इट बिकम्स वेरी डिफिकल्ट टू सेपरेट x and y. Okay, यहाँ पे x and y are already separated. So now you get it why you will put sigma z is equal to 0 in this equation. Yes or no? Guys, yes or no?
Yes.
So now equate this entire equation to 0 and tell me the value of yna divided by xna. आंसर यही आ रहा है, yna and xna. Is everybody getting this? Simple है ना? yna xna same करो, this denominator is same, so denominator will go to 0. So this automatically comes out to be minus of my xx upon mx iyy. Yes or no? Yes or no guys? ये तो 2 मिनट का ही क्वेश्चन है.
हाँ भैया.
Okay, सबका आंसर आ गया? Right, perfect. So this is where you call this as tan alpha. न्यूट्रल एक्सिस की कोई पोजीशन नहीं मिलती है हमें एज सच इन टर्म्स ऑफ कोऑर्डिनेट. व्हाई? बिकॉज मैंने पहले ही कहा था सेंट्रोइड एंड न्यूट्रल एक्सिस विल कोइंसाइड. सो वहां पे वाई ए जेड ए सब कुछ 0 हो जाएगा, वाई एन ए जेड एन ए विल बी 0, बट ओनली बिकॉज न्यूट्रल एक्सिस एंड सेंट्रोइड विल कोइंसाइड हियर. सो दिस इज द पॉइंट. यहाँ पे वाई एन ए एंड एक्स एन ए बोथ आर 0. यस और नो? है ना?
हाँ भैया.
है कि नहीं? क्योंकि ये न्यूट्रल एक्सिस ऐसा नहीं है, ये न्यूट्रल एक्सिस बाहर की तरफ आएगा. दिस इज जस्ट फॉर क्लैरिटी, इसे परपेंडिकुलर बनाया. दिस इज गोइंग टू गेट 0 एट द पॉइंट. ठीक है, बिकॉज न्यूट्रल एक्सिस एंड सेंट्रोइड विल कोइंसाइड, और एक्सिस तुम्हारा हमेशा सेंट्रोइड पर होता है. सो न्यूट्रल एक्सिस विल बी 0, कोऑर्डिनेट 0 होंगे, बट योर इंक्लाइनेशन, यू विल गेट योर इंक्लाइनेशन, योर tan अल्फा. ठीक है, तो तुम्हारे पास अभी tan अल्फा का फॉर्मूला आ गया है. So this is the formula of your tan alpha, correct? Yes or no? Now you can do a little bit of experiments. ये तुम्हारा homework है. Try your experiments with this. पहले अगर तुम symmetric section लोगे, if you take a symmetric section, I'll write something here. For every symmetric section, ठीक है, your I x y will be 0. Yes or no? Yes or no? I x y 0 होगा. Why will I x y be 0? क्योंकि symmetric section में all the points are at equidistance to each other. Let's say this is the point, this is a section. So इस section में जितना far is my point x, उतना far is my point minus x, right? जितना far is y, उतना ही far is minus y. Yes or no? अगर इसके coordinate लिखूंगा मैं, तो this goes 1 1, this goes minus 1 1, this goes minus 1 minus 1. So do you see every point is cancelling out itself? 1 minus 1. Yes or no? Guys, दिख रहा है तुम्हें?
Yes.
Exactly. For that is why for every symmetric section, you will have this, that all the points will be IXY will be 0. So when you do that, try doing this. Try putting IXY is equal to 0 in this equation. In this equation, you will find a very interesting correlation, which is mx by ixx into y, iyy into y, my ixx, ixx into yx. Okay, so that will be your equation for symmetrical bending, right? Symmetrical bending will be an equation over here. ये symmetrical bending हो जाएगा. Symmetrical bending for a symmetrical cross section. Symmetrical bending for ix y is equal to 0. इसका इक्वेशन तुम खुद लिखोगे अपनी नोटबुक में अभी इसी वक्त. इट्स अ होमवर्क फॉर यू. ओके, मूविंग ऑन नेक्स्ट. Now you got the equation of unsymmetrical bending. Then you have the symmetrical bending equation at ixy is equal to 0. So यहाँ तक सबको समझ में आ गया guys? In the next 10 minutes the lecture will end, don't worry. यहाँ तक समझ में आ गया?
Yes.
Okay, last thing जो मैंने कहा था, there are two types of unsymmetrical. We just finished one where the cross section is unsymmetrical. Now what about loading is unsymmetrical? For unsymmetrical loading, it is the simplest. You just have to make vector notation of the loads into this. The difference was because cross section was unsymmetrical, that is why we vectorize the form of distance. Now when loading will be unsymmetrical, we will divide the loads, the force and the moments into vector forms. Do you get the difference? Yes or no? Guys, yes or no? नहीं समझ में आया? दोबारा बताता हूँ. ये देखो. Let's say there is a circular cross section. Okay, for a circular cross section, this is symmetric. That means your centroid and everything, neutral axis, everything is fine. Ix, y is 0. Okay, everything is coinciding. But let's say you have a moment. अब ये है y axis and this is x axis. But let's say you have a moment like this, which is acting. This is the moment, and moment is acting at an angle theta. ये फिगर समझ में आया सबको? Yes or no?
Yes.
हाँ. So what you are going to do is you're simply going to do this. Let's move up. So do you see the difference? We'll just focus on the first figure. Figure number 1. We'll not focus on the second figure right now. Okay? We'll only focus on the first figure. So if you're looking at the first figure, ध्यान से देखो. My my is like this. अगर यहाँ पे तुम arrow बनाओगे, so your arrow is a double head arrow like this. Your mx is in this direction. Yes or no? दोबारा imagine करो उस same figure को. Y axis. Yeah. Somebody saying anything?
My will be in the opposite direction.
Yeah. Okay. Correct. So you see, can you imagine my to be like this? Yes or no? No, you cannot imagine because obviously, yeah, what you said is right. My will be in the opposite direction. Okay. So this is given as per the question. My is in this direction. Perfect. Yes or no?
Yes.
Your mx is in this direction, right or not?
Yes.
And what is the direction of your m? Is your m acting like this? At an angle theta? Tell me.
Coming out of the plane.
Coming out of the plane? हाँ तो ये ऐसे ही बनेगा ना arrow. If you take an arrow from m, what is the direction of this arrowhead? Will it be like this? Put your thumb over in the double arrowhead direction and then tell me, क्या m ऐसे ही आ रहा है?
Yes, yes.
समझ गए? ये वाला m है ना? mx and this is my. So now my job is, और ये क्वेश्चन गेट 2019 में आया हुआ है, ठीक है? Exactly by the book PhD Megson का क्वेश्चन आया था. So what will you do? हमने m को पकड़ा, m will be mx plus my. बट अब इसे mx और my के कॉम्पोनेंट्स में ब्रेक करो. How will you break it? Okay, write it like this. थोड़ा आसान होगा तुम्हें समझने में. mx is equal to m and my is equal to m. Tell me how. mx को क्या लिखोगे तुम? m
Cos theta.
Sin theta.
yes. So can you explain sin theta कैसे और ये cos theta कैसे होगा? अब इस चीज को बहुत ध्यान से समझना, ठीक है? My mx is in this direction. I'll erase it right now. mx को मैं हटा दूंगा. हम सबको पता है mx किस डायरेक्शन में होगा, राइट और नॉट? पता है या भूल गए? याद रखना, बिकॉज आई ड्रॉ इट वंस अगेन. मैं अभी सिर्फ m को लेके जाऊंगा. m and this is theta. Right? So this is how it is showing me. For theta less than 90, जो पहला फिगर है, that is theta less than 90, where mx and my दोनों पॉजिटिव होंगे, right? So how will you see that? See, bending moment m is at an angle theta to the x, right? Now for both cases of m, let's say mx is equal to m sin theta. mx is equal to m sin theta. ये हटाने दो मुझे, ठीक है? mx is in this direction, m is in this direction. ये ऊपर से दिखाया हुआ है. अच्छा, this is on the upward plane, तभी इशू हो रहा है, right? So I'll just remove this part. Is in downward directions, right? Arrowhead इसका ऊपर बनाएगा कोई? Can anyone try to tell me how to make the arrowhead over here?
Hello.
Yeah, tell me.
In arrowhead diagram between m, mx and my, the theta is angle between my and m. Is it?
Theta is the angle between m, y and m. Correct. Yes, yes, correct. ठीक है, तो ये एरो हेड डायग्राम सही बना है अभी. नाउ इज इट करेक्ट? थोड़ा क्लियर आया? यस और नो गाइस?
हाँ भैया.
सही बनाया मैंने? डोंट रेफर दिस डायग्राम. इन्होंने यहाँ पे ये गलती की है, इन्होंने एरो हेड नहीं दिखाया है और इन्होंने यहाँ पर थीटा दिखा दिया है. बट ये थोड़ा नीचे होगा इफ यू गो विद एरो हेड डायग्राम. ये तो प्लेन पे दिखाया है, इसीलिए यहाँ पे ऐसा दिखा है. इफ यू डोंट रेफर दिस डायग्राम, इस डायग्राम के मीनिंग के हिसाब से इज दिस करेक्ट व्हाट आई हैव ड्रॉन राइट ओवर हियर? ये वाला पार्ट करेक्ट है ये डायग्राम? टेल मी. सही है ना? कंपेयर कर लो. mx is in this direction as this, my is in upward downward direction, m is in this direction and theta is with my. Yes or no? Correct?
Yes.
हाँ करेक्ट.
Okay, correct. So अब यहाँ देखो, अब तुम्हें दिख रहा है m is equal my is equal to what? M cos theta.
Yes.
And mx is equal to m sin theta. Right? So this is just one example. समझ में आ गया ना? So this is just one example when your loading is different. Why did not give force? Because force को वेक्टर फॉर्म में डिवाइड करना बहुत आसान है, क्लियरली दिखता है. बट मोमेंट्स के साथ ये कंफ्यूजन होता है. सो जस्ट कीप इन माइंड दैट तुम्हें पहले मोमेंट डायग्राम वेक्टर का बनाना पड़ेगा एंड सॉरी मोमेंट का वेक्टर डायग्राम बनाना पड़ेगा एंड देन यू हैव टू रेजोल्यूट इनटू वेक्टर्स. ओके,